Hello dear students, in this lesson we'll talk about encapsulation and we'll learn what is the role of encapsulation principle in the object-oriented programming. In this lesson we'll talk with you why do we need encapsulation and how we can implement encapsulation in our programs. We'll learn with you access modifiers and on real code examples I will show you how you can use them. I will share with you my practical experience, when to use which modifier, and we'll learn rules which we need to follow during overriding. So, let's jump to examples to understand this topic better. What is an encapsulation? Encapsulation is a principle that teaches us to group data and behavior, those are our fields and methods, together as a single unit. We can control access to interfaces, classes, fields, methods. To control access, we have four main access modifiers. They are public, protected, package private, or default, private. Let's start one by one to understand the difference on the specific examples. To not show you how access modifiers work with classes, fields, and methods separately, I will show you how access modifier works with methods. Because these modifiers control access to elements and the way how they work are similar no matter whether you try to get access for field or method. Okay, so imagine we have some class, let's call it class A, and inside this class we have the method with public access modifier. That means you can access it from any point of your program. For example, here you can see demo class which is outside of our package number 1. I can create the instance of class A and call a public method on it. Now, imagine I have protected method do something too. Will I be able to call it from demo class? Unfortunately no. Why? Because I can get access to protected entities only inside the same package or in a child class. If only I had demo class inside the package number 1, I would be able to call methods do something too. Do you see here? I can call this method when demo class is in the same package with class A. Also here I have child class of the class A in package number 2, and inside the methods do something class B, I can call protected methods do something too. So now you understand that I can access protected entities in case they are in the same package or in child classes. Our next modifier is package private. You can see that do something class B doesn't have any access modifier specified. That is not true. When we don't specify access modifier, that means that access to this entity is a default. So usually absence of any keyword that associated with access modifier is called package private or just default access. So let me get back to demo class in package number 1. In scope of this package, I will create object of the class B type. And on this object, I call do something class B method. And you see that I have compilation error. But if I create object of class B type inside the package number 2 and call the same method, it is possible. Because default access is only within the same package. Taking into account this demo class and class B in the same package, we don't have compilation error. And last but not the least modifier is private modifier. Everything is easy here. You can access private entities only in scope where it was declared. For example, I have private method declared in this class and I can call this private method wherever I want in this class. But I can't call this method outside of the class even in the same package. If I would try to do so, I see compilation error. So now you understand the difference between modifiers. I believe you understood that encapsulation in OOP language can be implemented with the help of access modifiers. And you know how they work. Knowing this, during the planning of code architecture, you can choose access modifier which works the best for you. I want to share with you which modifiers you will use most of the times. In 99% of cases you will use either private or public. This is because you may have very few business cases when you want to keep something visible only in scope of the package or only in scope of the package and child class. Most likely you will implement interfaces and would like to keep this behavior public. Sometimes you will have methods which are needed only for this class and you will keep them private. Usually all fields have the private access modifier, because you want to control interaction with your object. So now you understand that default and protected modifiers are not used very often. And last thing for today which I wanted to discuss with you is the rules for access modifiers during the method overriding. The rule is simple. When you override method, you can't reduce the visibility of the inherited method. For example, in class A, we have doSomething method, class B extends class A, and class C extends class B. Is that clear? And now I want to override doSomething method, and I override it with protected modifier. Just to recall, it was public in parent class, and I have compilation error here, because we can't narrow access. On the other hand, in class B, doSomething class B method has default access modifier. I can increase access level. And you can see here that I override method with public modifier and there is no compilation error, because you can extend access level. That's it. Now let's recall what we have learned today. Today we learned what an encapsulation is. We know that access modifiers can help us to implement encapsulation principle in our code. Also, we learned the difference between public, protected, default and private access modifiers. We discussed which modifiers developers use more often, and we saw specific rules which we need to follow during method overriding. That's all what I had in my agenda for today. Thanks a lot for your attention and see you in the next lesson.